At 3:17 in the morning, the terminal is already moving. The floodlights burn white across 40 acres of stacked containers. Metal scrapes against metal. Diesel engines idle in formation. No one is rushing. They have done this 10,000 times before. A container ship sits against berth 302. She is 1,200 feet from bow to stern. Her hull rises 7 stories above the waterline. 23,000 steel boxes are stacked on her deck. She arrived from Shanghai 41 hours ago. The gantry cranes are already in position. Each one weighs 1,800 tons. They stand 350 feet tall. Their legs span the width of the ship. Steel cables hang from the spreader bars, waiting. Marcus Chen sits in the crane cabin 200 feet above the dock. He has been operating this crane for 11 years. His hands rest on 2 joysticks. The 4 monitors show different angles of the spreader bar. The radio crackles. "Crane 7, you're clear to lift." The spreader bar descends. Chen moves it with precision measured in inches. The bar locks onto a 40-foot container. 4 twist locks engage simultaneously. Hydraulic pressure builds to 3,000 pounds per square inch. The container lifts 80 feet below the Longshoremen watch. They stand in groups of 3, yellow hard hats, reflective vests, radios on their belts. One of them signals with his hand. The crane stops. Another container is coming. The container moves across the terminal. Chen rotates the crane trolley. The spreader travels at 60 feet per minute. It crosses the ship's width in 90 seconds. Below, a chassis waits. Driver inside. Engine running. The container lowers. 4 feet, 2 feet, 6 inches. The twist locks release. There's 28 tons of cargo now rests on the chassis. The truck pulls away. Another chassis takes its position. The cycle begins again. This is berth 302 at the port of Long Beach. It processes 1.2 million containers every year. 48 gantry cranes operate across 6 terminals. They never stop moving. Day shift, night shift, the work continues. The ship's manifest lists 11,400 containers for unload. Another 8,200 containers wait in the yard for loading. Each container has a number. Each number has a destination. Nothing moves randomly. In the operations center, Maria Rodriguez tracks every move. 3 monitors show real-time crane positions. Another screen displays the vessel's stowage plan. She coordinates 17 cranes across 3 ships. Her shift started at midnight. The stowage plan is calculated by algorithm. Weight distribution, container height, destination port, hazardous materials, refrigerated cargo, every variable is mapped. The computer decides what goes where. Container 473B arrives on chassis. It weighs 31 tons. Inside, automotive parts from Detroit bound for Tokyo. It will be loaded in Bay 12, Tier 4, Row 18. Chen receives the coordinates on his screen. The spreader descends. Locks engage. The container lifts. Chen swings the trolley back toward the ship. 90 seconds later, the container hovers over its designated position. He lowers it between 2 existing stacks. 6 inches of clearance on each side. David Park works the deck. He is the lashing crew supervisor. His team secures each container with steel rods and turnbuckles. A single loose container can shift the ship's balance. Nothing is left to chance. By 6:30, the sun rises over the harbor. The cranes cast long shadows across the terminal. 2,400 containers have been moved. The operation is 37% complete. Rodriguez checks the progress chart. They are 6 minutes ahead of schedule. The refrigerated containers require constant monitoring. They carry frozen seafood. Temperature must stay at -18 degrees Celsius. Power connections are checked every hour. A temperature spike means total cargo loss. Container HAZU 7834562 holds hazardous materials, chemical solvents, Class 3 flammable liquid. It must be loaded in a designated hazmat zone, away from heat sources, away from sparks. Fire suppression systems nearby. The terminal operates 3 shifts. Each shift lasts 8 hours. Crane operators, longshoremen, chassis drivers, lashing crews. 240 workers per shift. 720 workers per day. The port never sleeps. The chassis fleet numbers 800 vehicles. Each chassis can carry up to 40 tons. They run on diesel. They move containers from ship to yard, from yard to rail terminal, from rail to highway. The containers never stop moving. The rail terminal sits adjacent to the container yard. Double-stack trains wait on 16 tracks. Each train can carry 280 containers. They will travel to Chicago, to Memphis, to Dallas. The containers go inland. At 8:45, Chen completes his 100th lift of the shift. His arms ache. His eyes burn. But the rhythm continues. Descend, lock, lift, swing, lower, release, every 90 seconds. Every container identical in process. The terminal can process 12,000 container moves per day. At peak capacity, that number reaches 15,000. But weather delays ships. Equipment breaks down. Schedules shift. The actual throughput varies. Today, they will hit 11,800. At 10 o'clock, the first ship completes its unloading. The last container leaves the deck. Chen moves his crane to loading position. Now the reverse process begins. Containers from the yard onto the ship, bound for Asia. The export containers hold American goods, soybeans from Iowa, cotton from Texas, scrap metal from Michigan, machinery from California. Every container represents American production moving to global markets. The Port of Los Angeles handles 40% of America's container imports. Long Beach handles another 30%. Together, they form the San Pedro Bay Port Complex, the largest container gateway in the Western Hemisphere. By noon, the temperature reaches 78 degrees. The steel containers bake in the sun. Heat radiates from the pavement. The crane cabins have air conditioning, but it struggles to keep up. Chen drinks water every 20 minutes. The container identification system uses RFID tags. Each container broadcasts its number, location, status. The terminal's computer network tracks everything in real time. No container is ever lost. At 13:30, a second ship arrives. The MSC Isabella, 1,400 feet long. Capacity, 24,000 TEU. She carries consumer electronics from South Korea, automobile parts from Japan, textiles from Vietnam. The cranes are already waiting. Rodriguez shifts crane assignments. Cranes 4, 5, and 6 move to the new vessel. Cranes 7, 8, and 9 continue with the first ship's loading. The coordination is constant. Every crane must know its position. Every operator must follow the plan. The longshoremen work in teams. Each team has a specific function. Container handlers, lashing crews, equipment operators, safety inspectors, radio communicators, everyone knows their role. The system depends on it. At 1500, the first ship is fully loaded. 8,200 containers now rest on her deck. The lashing is complete. The manifest is closed. The harbor pilot boards. Tugboats take position. She will depart in 40 minutes. The Port of Long Beach handles 8.1 million TEU annually. Each TEU represents one 20-foot container. That equals billions of dollars in goods. The economic impact reaches every American state. This is where global trade becomes physical. Chen's shift ends at 1600. He climbs down from the crane cabin, 238 lifts completed, 0 incidents. He will return tomorrow. Another ship will be waiting. The work never stops. The second shift arrives. New operators climb into the crane cabins. New teams take the deck. New drivers start their chassis. The transition is seamless. The containers continue moving. By 1730, the MSC Isabella has processed 4,100 containers. The operation will continue through the night. Rodriguez will hand off to the night supervisor at midnight. The plan will continue. The numbers will update. The ships will keep coming. The terminal's maintenance crews work between the shifts. They inspect crane cables, check hydraulic systems, grease the trolley wheels, replace worn parts. Preventive maintenance prevents failures. Downtime costs millions. The container tracking system logs every move. Timestamp, location, container number, destination. The data feeds into the global shipping network. Companies track their cargo in real time, from factory to final delivery. The environmental regulations are strict. The cranes run on electric power. The terminal uses shore power for docked ships. Emissions are monitored. Air quality is measured. The port works to reduce its carbon footprint. Security is constant. Cameras monitor every section. Radiation detectors scan each container. Customs inspectors examine suspicious cargo. Drug detection teams patrol. Nothing enters America without inspection. At 1900, the floodlights take over from the sun. The terminal glows white. The work continues. Crane operators can see as clearly as daylight. The night shift operates at the same pace as day. The American economy depends on this flow. Consumer goods, industrial components, raw materials, finished products. Every container represents a transaction. Every transaction represents employment. The system must not stop. By 2100, the MSC Isabella's operation nears completion. 2 more hours remain. The night supervisor monitors the final loads. The ship will depart at 6 a.m. tomorrow. Another vessel already waits offshore. The terminal operates 365 days per year. No holidays, no weekends. Christmas Day looks the same as Tuesday in March. The global supply chain does not observe American calendars. The containers must move. The ship does not stop. Another port waits. Another load waits. Another crew waits. The containers never rest. Neither does the terminal, neither do the operators. This is how America's economy moves, one container at a time, every 90 seconds, forever.